Hi everyone, welcome back. In this video, we will solve the leet code problem, sum of root to leaf binary numbers. And we will do it using a clean and efficient depth-first search approach. By the end of this video, you will clearly understand the idea and the math behind it, and how the recursive solution works step by step. You are given a binary tree where each node has a value 0 or 1. Each root to leaf path represents a binary number, starting with the most significant bit. For example, if the path is 0, 1, 1, 0, 1, this could represent that number in binary, which is 13. So our task is simple. We need to convert every root to leaf path into a decimal number, and then return the sum of all those numbers. So the approach here is, imagine walking from root to the leaf, and as you move down, you are essentially building a binary number digit by digit. And once you reach a leaf node is the node that has no children. The number is complete and we add it to our final answer. The key insight here is that we don't need strings at all. Instead, we can build the number mathematically. How? At every node, we take the current number, then shift it left by 1 bit, and add the node's value. In code, this could be written as current equal current number shifted 1 bit to the left and ORed with the current node value. This perfectly mimics how binary This perfectly mimics how binary numbers are formed. Let's take an example, the leftmost path in this tree. At the beginning, our current equal 0. Then, as we visited the first node, which is the root, then at this point, the current will equal the current value shifted 1 bit to the left and ORed with the root value, which is 1, and that will give us 1. Then, moving to the next node in the bus, which is 0, I repeat that again. I'll shift the current value, which is currently 1 bit to the left, and OR it with the root value, which is 0. So the result will be 2. And finally, the last node or the leaf node, currently we have 1, 0. Just shift it 1 bit to the left and OR it with the current value, which is 0, and that will give us the value of 4. And so on and so forth for the rest of the passes. To explore all root to leaf paths, depth first search or pre-order traversal is the natural choice. We pass the current number down the recursion, and each recursive call represents moving one level deeper in the tree. And when we finally reach a leaf node, meaning it has no left and no right child, we know the binary number is complete. And at that point, we simply return the value we have built so far. No further recursion is needed. Let's walk through the code. I'll start with a helper function called depth first search. It takes two parameters, the current node and the number built so far. So we'll take tree node pointer and an integer number num. If the root is null, then we will return 0. Otherwise, we update the number by shifting left and adding the node's value. And or it with the current root value. If the node is a leaf, we return this number. So if not, if it is not a leaf node, we recursively compute the sum from the left subtree and the right subtree, and finally return their total. And that is the implementation of our helper function. The main function simply stores the depth first search from the root with an initial value of 0. So we just need to return our depth first search function with the root and 0. Let's run it to make sure no compilation error. And as you can see, all the test cases pass. Let's submit it. So I would say this solution is a clean one. Why? Because this approach avoids global variables. Each recursive call returns its contribution directly, and the logic is simple, predictable, and easy to debug. This is exactly how recursive tree problems should be written. In terms of complexity, the time complexity is O of n because we visit every node once, and the space complexity is O of h, where h is the height of the tree, and this is due to the recursion stack. As you can see, this solution is efficient, elegant, and easy to explain in interviews. If you understand this pattern, you will be able to solve many similar tree problems with confidence. And that is the full explanation of this solution. Thanks for watching. and happy coding. Bye.